Good evening, everyone, again, and thank you for coming to our front-end engineering event tonight. We're going to have a couple of tech talks from Jean and Andy, and we'll have time for Q&A after each tech talk. So if you could please hold them until then. Without further ado, I'd like to introduce Jean, who's going to talk about integrating non-React libraries in a React setup. Jean?
Yeah. Do you hear me? All right. So I'm Jean. I'm a front-end engineer here at Facebook. I work on the ads creation interfaces, more particularly the local one, especially if you ever created ads on Facebook. And I'm going to talk about non-React components in a React application. So basically using a non-React component that would already exist in your React application. Right. So let's start by talking about the problem. So how many of you are familiar with React, first of all? And used React, like, for real? Yep. Yeah, there's a difference between knowing about React. So React does allow you to declare your interfaces, how it should render in a very declarative way. So basically, everything looks like this. We have in your components a main render function, and you return exactly what you want to display. And every time anything changes in your model in React, you re-render everything. That's the general idea. So you're sure by using this technique that everything will be always up to date all the time. React component is basically a pure function from a functional standpoint that takes only inputs, properties, and the local state as input and gives a DOM representation as output. So it makes things very easy to maintain and to update. And that's the real perk of React.js. On the other hand, like most libraries that were created previously before React, like, for example, jQuery's plugins, there's a lot of jQuery plugins out there, and they're on this model where you just select some DOM element, pre-existing DOM element, and you will activate the plugin, and then you will add some handlers and customize and so on. The problem is it's kind of incompatible with React because what do you put in your render function if you have a React application where everything is defined like declaratively, and you want to use some existing UI libraries that is not declarative but more imperative. So we encountered this very case with Leaflet.js. So you probably have heard of it. It's like a sliding map renderer. Very, very nice library, works really well. So for Facebook, it's used in Facebook, for example, for pages showing a location with a pin. We don't want to reinvent the wheel, but still we want to use that from a React application. So we want to use directly that. We'll not reinvent and make our own React-based renderer. So this is what creating a map in Leaflet looks like. It's simple. It works really well for a simple content-based document. But if you have a complex application where your markers will, you want to remove markers or update them, move them, etc., it becomes very hard to maintain. You have to lots of state in behind. Hence the idea of wrapping the Leaflet.js library inside a component of our own, a wrapper. And this will be the single point of contact with the internal library that is Leaflet. So that from any point in our application, any other component, for example, location map showing a pin, showing a location page map, we'll be able to use it just like any other React component in a declarative way. So what we want to be able to do is to transform this that is imperative into this that is much more declarative. So instead of creating uns, it looks like we re-render the whole map every time and specifying our different layers declaratively. And then we need the wrapper to handle updates during the lifecycle of the application. So it asks a few questions. It's how we expose Leaflet's internal state, like the view that you can move, the user can move the view, pan the view, zoom, etc. How do we expose that as a React? And how do we expose Leaflet's own concept of layers in a way that is easy to use? So wrapping, let's talk about the principles we use for wrapping leaflets. But those can be used like are pretty much the same for any component you want to wrap and use just like as a React component. So the first, all right, there's a, whatever. All right, first of all, we'll discuss how the general structure of such a wrapper is to use React lifecycle methods. So in addition to render, where you declare a thing declaratively, you have some lifecycle methods like component did mount, component did receive props, these kind of things, called during different events of the component after the component has been re-rendered. And we'll leverage that to update and create the map, meaning that our render, because everything will be handled by the Leaflet UI, our render will just return an empty div. And that'll be like the anchor for Leaflet to create. And in component did mount, that is a special function React calls after a component has been rendered for the very first time. We'll simply create our leaflet map using the normal API. And we'll use getDomNode to grab the div we just created before as an anchor, as the root of the leaflet map. And lastly, we can pass directly the view as in the constructor of Leaflet. So this is component did mount. Component did receive props, that is just after subsequent renders. We'll just update the view and all the properties. All right, a second thing we'll talk about is to always keep the internal states consistent with properties. So what I mean by that is here you have a view that you pass from, let's say you want to center the view on the location. So you want the map always to be centered on the pin that represents the location. And there's a little subtlety here. Because we want the user to be able to pan the map. But here, we're specifying the view as a property. And in React, because it's declarative, what is rendered should always be consistent with the properties. So if we have that, we would expect the map to be always at the view specified, at the location specified. So this is very similar to what happened with React controlled input elements. So React provides wrappers around the input DOM elements, like a text input. If you just specify the value, then React will make sure the value always stays as specified. So basically, the field is read-only by definition. If you want the field to be editable, you have to specify an handler that will change the state somewhere or in a store if you use Flux. And then you will, when you re-render with a new value in your model, you will pass this new value. And then the field will become editable. So with the map, it's the same idea as with the input wrappers. For our map wrapper, we provide a callback on the change, and we'll have to take care of updating the view in the model and pass it from the state out prop. So what happened? This is the map creation. And then, so Leaflet.js provides this event called moveEnd that just indicates the user just panned the map. What we do is just call the callback on view change, and we expect the unclosing element somewhere in the application to render our map with the new view. In which case, there is nothing else to do because Leaflet.js internal state is already synchronized with the prop. So everything's fine. On the other hand, the enclosing element could decide that the new view is not what we want and choose another view. For example, if you want to limit the view to a geographical area, and if you pan too far, then we could imagine reset, in which case we will just synchronize Leaflet's internal state with the new prop. And there is one last case. If the enclosing element does not accept the new view and does nothing, so does not re-render, the problem is that in that case, the Leaflet.js own state, internal state, is not in sync anymore with the view that was originally passed. So for handling that, we set timeout, and we consider that in the next event cycle, if it wasn't re-rendered, then we reset the view to the original property that was passed, because this original render is still valid here. So consistency between properties and the internal state is super important because you really want the users of the wrapper for a non-React component to use the wrapper just like any other React component and not have to make any assumption about the behavior, the internal behavior. So you really want the props to be pure from the functional point of view and be like inputs, and you know exactly what is going to be displayed. All right. Leverage React's reconciliation algorithm. So the React reconciliation algorithm is what enables you to declare, to write your interface declaratively. And React, when you do a render of your whole application, React compiles the previous and the new DOM representation you return from render. And it compiles the two, and it will add the element you added. It will add them in the DOM for real. The element that were removed, it will remove them. So that's really the core of React.js. And we can use we can reuse this algorithm for adding and removing layers in Leaflet. So the layers are that. Tile layer, tile marker. So what is a layer in Leaflet? Leaflet has two concepts. It has a concept of controls. It's like a helper to put some, like the zoom buttons is a control. And then you have the layers that are going to move when the user pans the view. So markers and tiles, the background tiles, are layers. drawings, circles, paths, anything like that is a layer. And everything is going to move. So it's really the core of Leaflet. And the control, on the other hand, is just a helper for doing things on top. So we decided for our use case to drop completely the support for controls, because it's just as easy to make an overlay and render our own existing React components, standardized component that we use everywhere else in the application, like buttons. We have standardized buttons. So we'll just use standardized components for the controls. So it remains the layers. So the layers, we represent them as placeholders, because we'll see those are not really backed up by DOM elements. There is no, it's not going to render any DOM element. It's purely a Leaflet.js concept. But still, we chose to represent them as React components, as placeholder. And thanks to that, we'll be able to let React do the reconciliation. So when the marker, we decide not to render the marker, for example, and we replace it by undefined or null, then Leaflet will reconcile the old and the new. We'll talk about that a bit after. So I said earlier that the wrapper itself is rendering just a div as the root for Leaflet. It's not actually completely true. What we're doing, so div is here. What we're actually doing is we're wrapping each placeholder in a layer wrapper. And we'll expect React to reconcile the layer wrappers. And the layer wrappers will be in charge of detecting new layers, removed layers, and act on the map, on the in-map state to effectively remove and add those layers. So we use React child and map just to enclose every child. So basically, this is the hierarchy of our components. Now, so we rendered that at some point. Let's imagine we do a second render, and we decided not to display the marker. So replace it by undefined. So we'll not create any wrapper for this layer. And React will reconcile the components. And this component does not exist anymore. So React will call like the lifecycle function component did unmount or will unmount to signal that this component has been destroyed. And it will be in charge to remove the layer from the main wrapper. So basically, what happens when we create a layer? We use the same technique as for the main wrapper. In this component, there is this special lifecycle function that will be called as well. Component did mount. That is called, and in this, we'll call a special function toLayer in the placeholder that we will add to the map using a callback provided here. So we don't pass the whole map. We just pass those two callbacks that will allow the wrapper just to add and remove layers from the main wrapper, because we don't want the layer wrappers to mess with the map internal state. All right. So about the placeholder itself, it contains two special functions, toLayer. That just takes the props that were passed to the placeholder. So yeah. And just create an actual Leaflet marker layer. And then there is mutate. So if later you re-render the layers with other parameters, with other properties, so React did the reconciliation. So you're here, and it will call component did receive props. And so we'll be able to update the layer by using the special function mutate. It just checks what changed and updates if as necessary. So if the option changed, for example, we return false, and the layer wrapper is in charge of destroying and recreating the layer completely, because Leaflet does not provide any function to actually update the options. So when you have a layer in Leaflet, you have no functions to update options you set initially. So in that case, you have to recreate the whole layer. Or if only the coordinates change, then we can update using Leaflet's API, can update the internal state. You'll notice that, so we convert here from our own model that is just like a geocoordinate object to lat long, to a Leaflet lat long. And the reason why we're doing this instead of taking directly Leaflet's own data type is that coordinates is an immutable object. So that enables us to do things such as that, comparing directly the coordinates. And if it changed, we update it. If it was mutable, we'd have to compare explicitly the latitude and the longitude, for example, in this case, explicitly. So using immutable is more legible, is more maintainable. For this example, that's a simple object, just latitude and longitude. But if you have deeply nested objects and configuration objects, using immutable object makes things much simpler. All right. So yep, we worked on this, and now we use a Leaflet map in our applications very easily, just like any other React component, by using a declarative React way that we love and enjoy. Yep. So that's it. Any questions? Oh, yep. Yep.
How you test this? Do you bother to create a unit test for this library wrapper? Or
So
you do that in end-to-end testing?
It would be, yeah. So we don't unit test this specific library. It would be hard to unit test. You could unit test just the wrapper and mock the stateful library that is inside, indeed, to verify that it stays always consistent. Integration test would be much harder because since the inside library is stateful, it's much harder to test the whole stack rather than with the usual like React components. So indeed, if the wrapper is part of a bigger application and you want to do an integration test on the whole application, indeed that may be problematic. Or you can just test that it returns the div and test the wrapper itself in unit tests separately.
Trust the library.
Mm-hmm.
Trust the library.
Yeah, yeah. You have to trust the library using in behind, indeed. So I forgot to say, but it's not a perfect solution either. You always have some drawback, some trade-off. For example, we don't handle reorganizing the layers if you want to have a marker on top of another marker. But that depends on your use case. If you don't need them, like we didn't in them specifically, so we didn't implement that. But yeah.
You showed the child node being rendered at one point, which was the map marker, leaflet marker, and you showed the wrapper element, but you just passed the leaflet marker as a direct child prop, as a direct, as if you were putting in a JavaScript variable. How does the child actually get hold of the view that it's actually associated with? If that makes sense.
I'm not sure. So
if you go back to the one where you were doing the mutate, for instance,
right,
or the one prior to that, I think. Keep going. Keep
mutate.
going back further. Here, hang on, that slide. So you've got child there, which is just a React element, yeah?
Yep, that's so.
So how does child
children
get,
is like,
how does child actually get the view that leaflet is on? Wouldn't you need to
the view?
Wouldn't you need to pass the view, the map view,
So
PL to the child?
So the children don't need the view, only the map. The general map needs the view.
Okay, but doesn't the child mutate the view?
The child doesn't.
So
the
child
child
calls
mutates
functions
the
on
layer,
view,
the existing layers.
yeah, on that layer. So
Yeah.
basically,
So
how does that work?
the placeholders are creating and mutating the layer, the existing layer.
Okay, so where does that layer come from, basically?
So the layer come from the previous rendering cycle that happened. So the layer wrapper is holding track of the leaflet native layer. And the first time we render, there is no layer yet. So we create it from scratch. We're using 2-layer. And then the next time we render, we'll use mutate to update. So depending on the previous property this layer was built from, and the new property we want to update the layer to. Does that make sense?
Yeah, I think so, yeah. Go.
Firstly, this is really cool. Thanks for showing this off. I'm guessing this is working. This would work for other types of libraries as well, with the approach of putting in children and using the diffing algorithm. I'm curious, how has the performance been if you wanted to make, say, if there was like feedback coming from the user that was previously going straight into some library, that maybe there was like an event cycle that was going really fast. Have you encountered that scenario where you've had to like redirect it through React? Does that work well in this situation?
If you have like fast events, so for the view, for example, when the user pans the view, we used move end and not move. So move end happens only once when the view has been changed. We could use move. That happens like every frame, like super fast, every time that you move 1 pixel, basically. And the problem, indeed, is that every time there would be a move, you would render the whole React view, the whole React components, right? And indeed, that incurs like a slowdown. It's less performant than having than leaving Leaflet doing its own updates. And that's why we chose to use move end and abstract away like the animations or the transitions.
Okay, so this
side.
kind of gives you a scenario that works for things that don't require lots and lots of user sort of like fast feedback.
That's right.
And then you leave the imperative stuff under there.
Yeah.
Okay.
If there's a fast feedback, fast events, then you may have some trouble. You may have to do some more manual or keep state directly, because the slow part here is to go up the hierarchy and change the model and re-render with a new model, and you may have other components in your hierarchy that have nothing to do with the map, but they will still be re-rendered, and they may not be optimized, and so this slows down the whole thing. If you handle everything inside the wrapper, and you avoid those fast events, from leaking outside, then it will be fine.
Okay.
But yeah.
Cool, thank you.
Can you speak at all to like how sustainable you think it is to have to like basically wrap every external library that you want to use in React? Like I know Dart has sort of run into this issue where there's like the Dart version of the library and then the JS version, or like TypeScript version and the JS version. You feel like you're adding to like a increasingly bifurcated ecosystem?
Yeah. So what do you mean exactly? What's the...
Just like, do you think there are any downsides to having to be able to wrap a library in React before you can use it in React, given that there are other similar systems that you all, like, now I can't use the library until there's like a React, basically adapter for it, etc.
Well, yeah, it depends on the complexity of the library you want to wrap. I guess if you have a small, simple library, you can remake it from scratch in React. That'll just be better in a sense because everything will be handled directly in a declarative way. It'll be easier to maintain. So it's only useful when you have this complex but very well designed, well made library, and you really don't want to reinvent the wheel. So yeah, it's an added. It's more things to maintain, more things to deal with. So, but it's still faster, easier to make a wrapper than to make a sliding map renderer for React. So that's the idea. Does that answer the question?
Looks like this would work brilliantly with web components. Have you tried that with existing web components?
So I haven't.
Is this compatible?
So what level do you mean compatible? Really?
Well, it looks like you're building web components now in React by wrapping. Have you heard about the web components?
React components? Oh, are you talking about the web components like the DOM web component concept? So well, this is so what's the?
Is this compatible, or does this work with web components? Or?
Well, if you want to use, like for example, if you want to use DOM native web components in React, you can do so directly. There is no need for a wrapper at all because DOM components are just like any. So there's a recent change that was made in React recently. That's like where instead of having a predefined list of DOM elements, you could use like DFP, etc. Now you can use anything that is all in that starts with a small letter can be used. So you can use any web components that exist out there and directly, and the props will be passed as attributes to the DOM element. So yeah, in that case, there's even no need for wrapper. And if the components are well designed,
component is the wrapper.
Mm-hmm.
The component is the wrapper then.
Yeah.
Hello. You said you had to use move end because of performance issues. So is that because of React or this leaflet thing? Because I'm basically, if you imagine you have, let's say, 15 different components of, 15 different instances of the same component, and each one of them updates, let's say, 4 times a second, would that mean that React is the wrong solution for that sort of problem, or would React work with something like that?
Well, I think I'm not too knowledgeable about this, but I think if you have lots of updates and like if you want a really high frame rate, React obviously will incur like a performance penalty because every time you re-render, there's the whole algorithm, React algorithm rendering. So, I mean, it depends what you want to re-render because in React you can choose to store your like local state in the component. And when you have local state in the component, when you change the state, only this component will be re-rendered. So that's fast. If you pass everything as prop and you store all the data in a single place, like the Flux model, we have stores, and pretty much everything re-renders when it changes. In that case, that will be slower because the React algorithm will execute on a much bigger hierarchy of components. And so indeed, that may be slow. So I tried by just changing move end by move, and this works, but this is noticeably, you see that the frame rate is slower.
Right, but do you think that's due to React or the way this wrapper thing was written?
Yeah, that's due to the way to the data coming up, being modified in the model, and then the re-render of React. That's right.
OK, thanks.
It's because of the whole process, whole algorithm. But the React will be much faster if it renders only one component compared to a whole hierarchy. So that's the thing here. All right, I think we're
Thank you, Jean. Don't want to run out of time. Jean's going to be around anyway afterwards if you have more questions. I'd like to introduce Andy now for our next tech talk, and he's going to talk about rethinking native app development.
So my name is Andy Street. I work on React Native for Android, and before that I was working in Menlo Park on mobile and desktop web timeline back before timeline and React existed. And then the last couple of years I've been working on porting some of the parts of the Facebook for Android app from web views to native views. And now I work on React Native. So I guess just for context, how many of you guys do native app development for like iOS and Android? And this might be hopeful, but Windows Phone? Nice. OK. So I'm going to be talking about how Facebook is trying to rethink the way that we develop native apps, and specifically with React Native. So first, a little bit of context into why we made React Native. And that starts with the status quo of developing native apps on multiple platforms right now. So one of the biggest downsides if you're coming from a web development background and going to building native apps is the build cycle on native apps. So doing the compile, package, deploy. So let's say you want to change like the number of items you're fetching in your like search type ahead or something. That requires a full compile, packaging that up into an app, and then deploying it over USB or to your emulator. And on Android, if you even just want to change padding for something on a view, since that's done through the assets, it requires the assets to be rebuilt, repackaged into the app, redeployed. This can take, like, depending on the size of the app, like 5 to 10 seconds to 30 seconds to over a minute. And then you finally get your app on your phone, and it crashes. And you get to do it all over again. This is compared to the web development cycle, which is like, I change something, I refresh, I see it. It's way more fun. It makes you want to actually experiment with things as opposed to banging your head on the table or doodling. Next thing is a lot of the, at least on Android and iOS, the UI APIs kind of encourage this stateful, mutable management of UI. So I just pulled this kind of randomly earlier today from TextView in the Android code base. This is from something called set movement. And you can kind of see, like, trying to read through this code, there's obviously like a lot of assumptions around what calls might have happened before. It's not really clear if I'm going in here and changing it, what I need to be wary of. And it's just like when you can't follow the code completely and you don't know exactly the context you're working in, it's really easy to write bugs. Next thing is each of these platforms kind of has their own flavor of very similar APIs. So if I decide I'm going to learn how to write animations on Android, that does not mean that I can go over to iOS and start writing animations. Same thing with networking, storage. Like even if you want to like package up image assets to show in an app, it's very different across Android, iOS, Windows Phone. And we'll even get into this a little bit later, but like layouting is very different. If you want to lay out views in a certain way. On iOS, you have the linear constraint solver. On Android, you've got like whatever they've got with XML layouts, styling, touch handling. It's all just subtly different. And this kind of leads to having these siloed, separate platform teams because the domain knowledge on iOS isn't really applicable to Android or mobile and desktop web. So you end up kind of maintaining these separate teams. So that's kind of why we're building React Native, or why we think React Native is something worth investing in. So what exactly is React Native? It's a framework for writing native Android and iOS apps using React.js. So I'm going to emphasize 3 points here. First one is it is native Android and iOS apps. We're not rendering into a web view. We're not rendering into multiple web views in a navigator. We're rendering into the same components that you would be using if you were writing an app manually. The next thing is we're rendering it using React.js. That is not the same thing as saying we're rendering it using JavaScript. We're explicit about rendering using React.js, which I'm going to get into in a minute. Then the last thing is this is not aiming to be a write once, run anywhere solution. If you look at the iOS, Android, Windows Phone platforms, they each have their own look and feel, navigation experience. Fundamentally, the apps are different, and you're not going to render them the same using the same code. Some examples of that are just like hardware back button on Android, which doesn't exist on iOS, where you have like swipe to go back. You're supposed to use drawers in the action bar on Android as opposed to tabs on iOS. Why React.js? We've been using React.js on web for a couple years, and it's got some really nice properties that we want to bring to our native mobile development. First one is composable UI. So we have isolated components that can kind of be moved around and composed into larger functional pieces of UI. Pure render functions. So basically, given a set of props instead of state, you always output the same UI description. Makes code very easy to reason about, and when code is easy to reason about, it's harder to write bugs. One-way data flow. So since parents know about their children, children don't know about their parents, you have events and data propagates from the parents down to the children. Again, easy to reason about. And then the last one is the use of the virtual DOM. So I don't know how familiar all of you are with the inner workings of React. I hope you guys know about virtual DOM, but basically, when you call render, it kind of outputs a description of the UI, and then it's the framework's job to figure out the minimal set of changes to actually apply that description based on the last description it had applied to whatever the underlying layer was. This gives us two things. First, obviously, we do less UI operations because we're doing the minimal set of changes. But the nice thing is, because we're not directly touching the UI, we can generate that UI description off the main thread. And the main thread, if you're familiar with native app development, is a thing that once you start blocking it, that's when you start dropping frames. So this is a quote from Rob Bunke from SoundCloud. It was one of his reactions to the React Native announcement back in January at React.js Conf. I think he grasped one of the really important things here about React Native with the render function, the pure render function, and it not being about rendering JavaScript. So what's the basic idea of React.js? Like, how is this implemented? So with React on web, you basically have these UI descriptions made of like divs, spans, image tags. And at some point, the framework will translate them into these document.createElement calls that actually put it into the DOM. Pretty simple when we're rendering on Android. Instead of divs, we have views. Instead of spans, we have text. Instead of image tags, we have image. And at some point, instead of calling document.createElement, we call new frame layout, new text view, new image view. On iOS, pretty similar. Just UI view, UI image, UI label. So this is an example of a React Native app, a very simple one. It's just a button that shows how many times you clicked it. And it should look fairly similar to a component that you might write on web, except for view, text, and the inline styles there. So one of the things I talked about was the subtly different ways that platforms have of doing similar things. So with React Native, there is one consistent way to do layouting and styling, which is really nice. And Christopher Chadeau's keynote from React.js Conf on day 2 is really worth watching if you're at all interested in our decisions to use Flexbox and inline styles here. He goes into it for about 10 minutes, which I don't have time to do. But basically, we're supporting a subset of CSS called Flexbox that allows you to do things that used to be very hard, like centering an element vertically, which is ridiculous, apparently. And we want to co-locate the styles with where they're used so that we have a separation of concerns and not a separation of just technologies. So what are the goals for React Native? First is developer efficiency, and that comes in 2 kind of flavors. First is the maintainability that you get from React.js and writing like React-style apps. The second is really getting rid of that compile, package, deploy loop that native developers currently have to go through. Next one is just developer fungibility. So learning how to write React native apps on one platform allows you to automatically know some things about writing apps on another platform. Even though you still need to know some of the underlying concepts about that platform, you're able to more easily move over and apply more of your domain knowledge. Next one is shared infrastructure. So since we're sharing the same language and sharing the same framework, we can share some of the same infrastructure. And we're already doing this with Relay. Relay is another React-related framework that we announced at React.js Conf. There's a really good talk on that on YouTube I recommend checking out. Basically is a way for components to specify the data that they want to fetch, and then the parents will handle grabbing all of those specifications up from their children recursively up to the top until you have one fetch of the minimal amount of data, and then it kind of spits it back down through the tree. So if you move a component around, it automatically updates the fetch. We can also share business logic for things that aren't directly related to views. So if you have like credit card authorization that's kind of the same on iOS and Android, you can write a JS library one time. And really one of the most important goals is not being able to tell that you are using a React native app. We need native look, feel, behavior, and performance. If developers have to choose between user experience and developer experience, the good developers are going to choose user experience. The lazy developers might choose developer experience, but the framework won't get adoption. OK, so I'm going to get into a little bit of the technical details here of how this is implemented. Basically, on iOS, Apple ships the devices with a JavaScript executor, JSC, which is the JavaScript executor used with WebKit. On Android, we don't have consistent access to that, so we have to ship our own JavaScript executor. Basically, you have, when you load the initial like JavaScript bundle, JavaScript has a set of APIs that it exposes to native. Native has a set of APIs that it exposes back to JavaScript. They can then call each other using this serialized RPC format. It's actually really simple. I don't know if you can read that very well, but these like numbers basically just indicate a method. So they kind of agree on like, OK, 3,1 is going to refer to this method. 1,1 is going to refer to this method. And then you can send arguments across. And this whole thing that we call the bridge is pretty abstract. So we have a lot of flexibility in switching out how exactly that's implemented. And right now, it's actually implemented in slightly different ways on iOS and Android. So the next thing is because, so I forgot to mention, this is also asynchronous. So when you call a method, you'll get a asynchronous result if you like pass a callback or something like that. One of the nice things that this lets us do is, so I'd mentioned that you can calculate the UI descriptions without actually touching the UI hierarchy. So we're able to execute JS basically wherever we want to. We can execute most of the native modules basically wherever we want to, and it's only that point when you're applying UI changes that you need to execute on the main thread. This is also pretty easy to customize, so if you have like a single core Android device, you could run them all on the same thread if you want. OK, so I'm going to do a demo. If any of you guys watched Christopher Chadeau's, oh gosh, hold on. Yeah. OK, I think this is what I want. Yeah. OK. Cool. So this will probably look familiar if you watched Christopher Chadeau's keynote. This is our like movie apps demo. So first I'll like prove to you this is actually rendering, I guess. So to like React Native. So when I hit Command S to save this, we've got a file watcher running, and it's going to automatically update the app over here. So, and this is all native components. So this is like a native scroll view on iOS. It's got like all the bounciness that iOS developers love. And like if I search for something like, yeah, so this activity indicator over here is like the platform default activity indicator. If I go like navigate over, this is the, oh gosh, why can't I grab this? OK. This is the platform navigator thing. I'm not an iOS developer, so I don't actually know what it's called. I think it's called Navigator. But this is the native navigator. Anyway, cool. So I wanted to go through how easy it is to like make changes to this app. So I'm going to try to like, I'm going to play designer. I'm going to say there's a lot of ugly white space, and I want to bling this out. So like I said, we use inline styles and CSS. So first, and I should probably also mention this component is movie cell, which corresponds to one of these rows. So like this. Yeah. So if I go down here, and let's say that I want to make like this movie image the actual background of the row, the first thing that I'm going to do here is, so if you're not familiar with Flexbox, basically this is going to tell it to take up the full width of the parent view, make its height 150, and then take all its children and push them up to the top as far as they will go. So comment that out, save it. So now we have, all that did was like rearrange the children there. And then I'm going to use this cool thing, position absolute, with left, right, top, and bottom equals 0. So it basically just pulls the image out to the right size. Nope, because I didn't comment that out. See, it's live. There we go. And then so kind of the last thing is this image or this title thing's kind of ugly. So I'm going to come up here, tell it not to take up the whole width there. So now it's kind of smaller. And then just change the background color, add some margin and padding, and change that text to white so it's readable. And the size of this is different than it was before, but OK. Anyway, it's basically what I wanted for this demo. Yeah, and it still like works like this, and it's all still native. So yeah, really fast to be able to like make these changes as long as you know what you're doing in CSS, I guess. I kind of cheated by writing a lot of it already. But yeah, that's it. I'll try to answer any questions you guys have. Oh, actually, I meant to demo Redbox because that's pretty cool. Oh, I also that's why it was longer. I forgot to get rid of that. Okay, there we go. Yeah, there. That looks more like I originally saw it. So red box, basically, if you do something wrong, we don't hide the error in the console. Or, well, I thought that was actually going to crash it. Maybe that doesn't crash it. One of these is supposed to crash it. That should crash it. File a task. There we go. OK. So that's not a valid color format. Instead of just putting it in the console and stopping execution, it puts it in your face and stops execution, which is really nice. And then if you go and fix it, Command S, and it's back. So it's also really nice.
Yeah, just a really quick one. Does it remember any state when it refreshes? So if you're like, 5 pages into your app and then you change like a font size, does it take you back to the beginning of your app?
Yeah, right now it doesn't. There are some interesting talks we've been having, like with the React Router people, possibly doing like navigation using React Router and being able to like serialize your navigation state within the app. There's also some cool talks at React.js Conf about basically serializing app state. So if we could do something like that, serialize the app state, save it somewhere, refresh, and then load it back again, it'd be pretty cool.
Given I was probably the only guy who put my hand up with regards to native Windows Phone development, are you planning on supporting Windows Phone development?
I don't know if we are or not, actually. But
what a surprise.
People, so I mean, we've had the, the Flipboard people kind of had their own custom render of React for Canvas that they announced. We've got some patterns you can follow. So if someone wants to make it once we finish open sourcing this stuff, then feel free, I'll accept your diffs.
Cool, cheers.
Yep.
Hi. So just with regards to layout, is because you were talking earlier, and I guess anyone that's used Cordova, etc., knows the difference between kind of the native look and feel and the kind of the web view look and feel. In implementing it, is there really any loss of native look and feel by using the Flexbox CSS model as opposed to using the internal solver or whatever it might be on Android?
I mean, not that I've noticed. So with Flexbox, all that does is give you a way to like calculate top left width height, which is basically what the algorithm does on iOS and Android anyway. Yeah.
Cool.
How much of the React, the JavaScript library is actually in here, I guess? Like, is any of it running here, or is this something completely new?
No, this is mostly the React.js framework.
All right. So
I don't actually know exactly how much got changed under the hood. But I mean, the way that React was written, I think they only had to change like a couple functions to get this initially working, because it's
so it's just like a new output engine, I guess.
Yes, exactly. Instead of doing like the DOM create elements, it does some calls to one of the native modules and tells it to create elements.
Okay. A second question: is there any sort of plan to have some sort of web developer tools or anything like that, so you could actually like live edit your views and stuff?
Yeah, I think that would be super cool. That's something that we've kind of talked about. I didn't demo it, but we have like Chrome debugging support right now. We want to support really the full like React Chrome plugin. Being able to like hover over elements in the hierarchy and have them like highlight on the screen would be really cool. Having some way to like be able to go the other way too would be really awesome. There's like a lot of, green field here. There's like a ton of ideas and like not enough people to do it. So.
Okay. So I have another question.
Yeah.
You said you're using flags for the styling and stuff. So I imagine you pretty much developed your own engine for layouting that's using flags. So how compatible you are with the standard or with the current browsers, and how do you make sure that you're actually doing the same thing a browser would, I guess?
Yeah, so this is like one of my favorite parts of the project. This is like Christopher Chadeau's brainchild, and when I heard he did this, it like blew my mind. So basically what he did after deciding he wanted to support a subset of Flexbox, what he considered, I think, a useful subset of Flexbox. I wasn't actually there to figure out how he made that decision, but we haven't needed anything. He wrote just a bunch of tests, and then when he didn't completely trust that his tests worked, he just wrote a randomization thing, doing kind of random combinations of elements and then rendering it in Chrome, and then getting the output and comparing it to the output that he was getting from his algorithm. So yeah, there's I don't know how many thousand test cases that we have, but we've had bugs, in React Native, obviously, and I don't think any of them came from the Flexbox implementation, which is pretty amazing.
Good stuff. Cheers.
Hey, I absolutely love this thing. I remember watching it at JSConf, and it blew my mind as well. But I'm really curious. When you said when you open source it, someone can just write the one for Windows Phone. When are we going to get our hands on this GitHub repo? Because it would be great to write more sort of targets for this. And if you said it's only a couple of functions they had to do, it just seems tantalizing.
I thought it was a couple of functions that that they had to do to get it hooked up to React Native. A whole lot more work has happened on the platforms themselves. Yeah, we're trying to open source this stuff as quickly as possible and kind of trading it off against the work that we need to do internally. We want to open source something that's in a good state for people to actually contribute to, and the team has a limited amount of capacity, but we're working really hard on this really fast, so keep your ears open. So to the first question, the only apps that have been released have been on iOS right now. iOS was kind of our test bed, and the Android development started much later in the process, which is why we've had an initial open source release of iOS and not Android. But the Groups app on iOS renders a significant portion of the app in React Native. And then the recently released Ads Manager app on iOS is also completely written in React Native. And then what was the other question? Oh yeah, it's actually interesting the way that we kind of see porting apps. So I think it's going to be a common thing. You write an app for one platform in something like React Native, and you want it to exist on another platform. You want to reuse some amount of the code. I can't say that we've come up with really tested patterns here because we haven't really had to do it much. But one of the first things that we ended up doing when we started trying to port some of the apps was have stub versions of all of the iOS-only components. So if it's Switch, there's Switch iOS and Switch Android. There's, what are other ones? The tabs, there's iOS tabs that load natively on iOS, and then on Android, it's a JS version of tabs that renders bright red, so you never ship it. The Switch version, the Switch iOS Android file is just a red box that says this is not supported on this platform. So when you go and actually render and try to run an app that was built for another platform, it'll kind of run and you can interact with it it was you were on that other platform, but there will be a bunch of red boxes and stuff that are this thing isn't supported and you're doing it wrong and stuff like that. Yeah.
So perhaps a obvious question: how can we get access to React Native?
When we open source it.
So there's no special invite.
Yeah. Well, there was one for React.js Conf, but yeah. Yeah, I'm sorry.
Thank you. 2 questions on CSS. So you said this is a subset of CSS, right?
Yeah.
How much of CSS is there actually in there? Is there any concept of cascade for properties?
No. So it's just the property. So there's not class tags that then apply to some like set of elements and stuff. It's all done with inline styles.
Okay, so since it's a subset and there is no cascade, what's keeping you from actually inventing new properties to make this a better layout engine than CSS actually is?
I mean, I think it's probably because we haven't had a need for properties that don't already exist in some form. There'd probably need to be a good reason to break standards. Like, there are just benefits, I think, to sticking with what's there. If we needed something, I'm sure we would build it. Do you have anything in mind?
Yeah, we can talk about this afterwards if you want to.
Hi, so I've been playing around with React Native recently for iOS, and it's amazing. So one burning question that I have is how far along the Android implementation is of React Native. For example, could you build that example app in the Android version at the moment, or is it a bit too early?
So I was actually messing around with this yesterday. There were like honestly just a couple of bugs that I would need to go fix, but it's we're hoping to get it out there soon.
Cool, that's promising. Yeah. And my second question is, seeing as you don't have a JavaScript engine that ships with Android, as you said, like with iOS you get JavaScript core, does that mean that the apps that you package up for Android are much bigger because they have to ship a particular JavaScript engine as well?
Yeah, so unfortunately they're probably going to end up being bigger. You have to compare this to the size of native apps, though, that are on the order of like 40 to 60 megs, or at least some of the bigger ones. I guess you can get down to like 10 or 15 megs. The amount of space that you end up saving by shipping your code in JavaScript that's more compressible is pretty significant. We've actually done some experiments on this. As for the exact size of the executor, we haven't actually settled on the executor we're going to try to ship with Android. So it'll probably be somewhere between like 1 and 3 megs is like the general
that's cool.
thing.
And one more very small question.
Yeah.
Considering that you're shipping this JavaScript engine as well, how far back are you aiming to support with Android? So version 4 point something, I assume?
We're currently looking at supporting API 15 or 16 and forward. Part of it is that having, I don't know how familiar you are with Android, but having Choreographer on the system, which synchronizes UI updates with vsync, which is the frame rate, makes it a whole lot easier to write apps that actually like look good. And we can actually use some of the newer APIs. Gingerbread and Ice Cream Sandwich have been kind of dropping off more. New phones don't necessarily have better hardware, but they're mostly shipping with like KitKat.
Cool, thanks.
I saw recently that Google had spoken a little about their efforts to share code behind Google Inbox and go cross-platform, and they had a lot of like Java 2X, Objective-C, whatever. Yep. What are your thoughts on like React Native as compared to that approach?
So with that approach, I mean, you don't get some of the developer efficiency stuff that we were talking about. But I think it's definitely something worth exploring. I mean, even underneath the actual like React Native level where we have to build a framework on iOS and Android, we can probably share code there. So we're probably going to look for similar strategies. Yeah.
Awesome. I think we can wrap this up
right
now. We'll have Andy and Jean anyway. Stick around more for any more questions that you have. And there's also some more colleagues from Facebook. Actually, if I could get a show of hands from people from Facebook, just for any more questions that you might have. There's more food and drinks, so please enjoy the rest of the event. Thank you for coming.